everyone, and welcome to lessons 4.3 through 4.4, day 1. Today, we're going to talk about ways in which we can prove triangles congruent. Now, before we start talking about proving triangles congruent, here are some properties that we should probably keep in mind because there's things that we can assume sometimes from diagrams without having to be given that they are congruent. For instance, we use the vertical angle theorem that our vertical angles are congruent. This is oftentimes happening in these double triangle situations in which it kind of looks like a bow tie. So sometimes we call them the bow tie problems. And we are allowed to say that angle 1 and angle 2 are congruent to each other by the vertical angles theorem. Another property we've used before is the idea of the reflexive property. And reflexive property occurs when we have this common shared side, in this case with these triangles, and we are allowed to say that if we are looking at these as two separate triangles, ABD and CBD, that they share that side in common. So we would be allowed to say that side BD, segment BD, is congruent to segment BD itself. Okay, and again, that's happening when they are sharing a side in common. We also have talked a lot about midpoints or bisectors this year. So when we use midpoints or bisectors, when we are given a midpoint, in this case, if I said that D is the midpoint of our segment AC, we'd be allowed to say that AD is congruent to DC by that definition of a midpoint. And then either segment or angle bisectors are given when we are given, again, that keyword of bisect. So for instance, if I said that segment BD is the bisector of AC, again, we could say that those two pieces are congruent. So again, if BC is the bisector of the segment AC, then we could say that AD is congruent to DC. Okay, so beyond just a midpoint, it could be bisecting the segment, or more commonly, we use it a lot with angles. So if I said that this time ray BD is the bisector of our angle, in this case, it would have to be angle ABC. We're saying that we are dividing that angle into two congruent pieces. So we could say angle ABD, this little angle up here, is congruent to the other little angle CBD. So those are some things we're going to want to keep in mind as we work through proving triangles congruent. Now, what are the 4 ways we're going to talk about today to prove triangles congruent? Well, if you are given 3 sides congruent in one triangle, congruent to 3 sides in another triangle, you could prove the 2 triangles congruent. If you are given the side, the angle in the middle, and another side, you also can prove 2 triangles congruent. So again, the 2 sides and what we call the included angle, so the angle in between them, you're kind of making up the sandwich with the 2 sides and the angle. That's another way to prove it. Then we have angle, side, angle. So when you're kind of making the sandwich again, but this time your side is in the middle of your 2 angles. That's angle, side, angle. So again, 2 angles and their included side. Or we also have angle, angle, side. So when you have 2 angles and the side is not in between them, you could prove these congruent by angle, angle, side. Okay, these are the 4 ways we're talking about today. You may be saying, oh, well, why isn't side, side, angle a property of angle, angle, side is? We'll talk more about that in class, why that doesn't work. Or angle, angle, angle also will not work. Think about equilateral triangles. Just because they all are measured in 60 degrees doesn't mean they always have the same side lengths. So again, those 2 are not on the list, not able to prove them congruent. So each time we are given a figure here, and we want to decide are these 2 triangles or not, and which of the up above mentioned pieces we would use. Now, you always want to mark in these pictures any vertical angles or congruent sides by the reflexive property or the vertical angles theorem. If they're not marked, that is something we are allowed to assume by those 2 properties. So for instance, in this first one, angle OYT and angle SYE are going to be congruent because of the vertical angle. So we're allowed to mark that in the picture. This then gives us enough information to say that by angle, side, angle, and again, notice it matches on this one as well, angle, side, angle, that these two triangles would be congruent, and again, by that particular property. In the second picture, we are allowed to mark side ME congruent to side ME because of that reflexive property, right? It's shared side between the two. And then when we look at the two triangles, they have a pair of sides congruent from the reflexive, and then they marked two other pairs of sides. So we would say that these triangles are congruent by side, side, side. Now in this next example, notice we have two sides and the angle not in the middle marked. So again, we talked about how side, side, angle is not a way we can prove triangles congruent. And also if you look at the other one, while this one is side, angle, side, it's not the same order as that first triangle. So this would be an example where they are not congruent to each other because they did not match up. In example D, this is an example, though, where side, angle, side works. We have the two sides and the angle in the middle of the two marked congruent. So side, angle in the middle, side on both triangles allows us to say that these are congruent by SAS. In the next example, we have two angles and the side not connecting them in both of the triangles marked congruent. So this would be an angle, angle, side not in the middle. And then finally, in our last picture, they're giving us an angle, two right angles, right? They're congruent. They're giving us a side, but then they didn't give us enough information, another angle or another side. There's nothing we can assume. There's no vertical angles or reflexive sides. So this one would be not congruent because there's not enough information to prove them congruent. On the next page, we have a couple examples for you to try. Always remember in some of these examples that you want to mark any of your vertical angles congruent first, if they're there, or reflexive sides as you work through A, B, C, and D. All right, our last little bit then for today is asking, okay, if we want to prove these triangles congruent, what extra piece of information would we need in order to prove them congruent? Now, in this particular one, they start off by giving us a side and a side marked congruent, right? So we have one side. We actually are allowed to assume that angle JIH and angle EIG are congruent because they're vertical, so we don't need that given to us. What we would need, though, is another side. And in particular, it would have to be the side next to the angle so that we can make that the included angle. So we would say we would need side JI congruent to side EI in order to prove these two triangles congruent by side, angle, side. In the next example, they gave us a pair of angles. Okay, so we have the first pair of angles, and we're officially allowed to say the reflexive sides are congruent. DC is congruent to itself because of the reflexive property. So we would need another angle, and in particular, we would need these angles, these baby angles up top, to make this angle, side in the middle, angle. So we would say we would need to be given that angle ECD, this little angle right here, would need to be given congruent to angle TCD in order for these two triangles to be congruent by angle, side, angle. All right, we have one more down at the bottom. What extra piece of information would you need to be given congruent in order to prove these two triangles congruent by angle, side, angle? Thanks everyone for watching. We'll work more with these in class.